All right, so now we're going to kind of continue with the previous video, do a couple of quick examples of finding the amplitude and the period for a sine or a cosine function, and then we're going to get into adjusting or translating our graphs horizontally and vertically. So I got a couple examples up here to go with. We've got g of x, not a problem. G of x is the same as y. That doesn't throw us. G of x is equal to cosine of 2x, and we just want to find out what's the amplitude, what's the period, and I'm going to show you once you have that, it's going to be real easy to graph these functions. So remember, amplitude is our coefficient of our trig function. There isn't one there, so obviously there's nothing there. There's a 1 there, so our amplitude is 1, okay? So what that tells us is our graph is going to go up to 1, and it's going to go down to -1, because right now we're not doing any other shifts. So the center of our graph is going to be the x-axis, okay? Period, remember, period is 2 pi over b, so it's 2 pi over our b value. Our b value is the coefficient of x, so it's 2 pi over 2. Our 2's cancel out, so our period is pi, all right? So finding the amplitude and period, we've done it. Amplitude is 1, period is pi. To get the amplitude on our graph, we just go up 1 unit from the center, down 1 unit from the center. We're good there. Our graphs right now, because there's no horizontal shifts, are all going to start at 0. And our period, if you recall, is how far it's going to take to do 1 complete revolution of the curve. So we're going from 0 to pi. Start point, end point, okay? Now we have to find those other 3 points. The midpoint is halfway between 0 and pi, which is pi over 2. Okay, because half of pi is pi over 2. The first quarter point is halfway between 0 and pi over 2, or think about what's halfway between 0 and a half. That would be a quarter, so that would be pi over 4, right? And then we have to figure out what's halfway between pi over 2 and pi. Well, you can add them up and divide by 2. That's how you can always average numbers, or you can think about this. That's 1 quarter, right? That's 2 quarters, which is a half. That's 4 quarters, which is 1. So if I have 1 quarter, 2 quarters, 4 quarters, this must be 3 quarters. All right. Again, if you get all the same denominator, sometimes it's a lot easier to see this. So we have our quarter points, we have our max point, our midpoint, our starting point. Now we just have to draw the curve. And if you recall from the last video, we're doing cosine. So cosine is going to start at the maximum point, going to go down to the middle of the graph. Next quarter, it's going to drop to the minimum point. Next quarter, back to the middle of the graph, and it's going to finish where it started at the maximum point. And now we connect the dots, and we do that, okay? It's a curve. Please don't do this. That's an absolute value function, right? It's not straight lines. It's a curve, okay? So that's what that one would look like. Do the same thing here. Another example, we have f of x is 1/3 sine of 1/2. Oh my gosh, fractions, whatever are we going to do? Easy, they're fractions, we love them. Amplitude is the coefficient of sine, which is 1/3. Guess what? That's it. Just like we put a 1 here and a -1 here, space them out the same. Don't put 1/3 super close. Here's 1/3, right? Here's -1/3. You've worked with a fraction, you're done, at least with that one. All right, next we need to find out what the period is. So we're going to do 2 pi over 1/2. All right, well, now we've got a fraction divided by a fraction, so that's going to change that to 2 pi times 2, which is 4 pi. All right, so there is our period. So we're starting at 0 again, and we're going to 4 pi. So halfway between 0 and 4 pi is 2 pi. Halfway between 0 and 2 pi is 1 pi, or simply pi. Between 2 pi and 4 pi is 3 pi. And so now we've got all of our quarter points marked again. And now we have to draw the curve. It's sine. So sine is going to start at the middle point of the graph. It's going to go up to the max, back to the middle, down to the minimum point, back to the middle. And it's going to look like that. And now you've drawn your sine curve for this graph. So once you get used to this, and I know I went through it quickly, but I just want to show you that once I can identify what the amplitude and the period are, there's no other shifts, it's very easy to draw your graph. I told you in the beginning of the year, and it's been going on throughout the year, you need to get used to fractions because you're going to be using a lot of fractions since we're going to be using them when we do radians, but that's what it's going to look like. Okay, so hopefully that helps out because you're going to be doing this as part of the steps you're going to take to graph it when we have horizontal and vertical shifts. I know you've been waiting for it, so here it comes. All right, so we're going to add a couple more letters to our formula for the sine and the cosine function, but you've seen them before, and hopefully you remember what they are. So if we have y equals a sine, just like we had before, okay, of b, but now, remember before we just had an x here and that was it, but now we're going to have shifts. And if you remember when we did a parabola, to move things left and right, we had parentheses. Well, we're going to have parentheses in this as well, and we're going to have, just like we had before, x minus h. Remember h? We had x minus h squared when it was a parabola, and that showed us left and right movement. Same exact thing here. And what was the other letter that we did for vertical? It was k, so we're going to have plus k. Same letters. They work the exact same way as they did when we were graphing parabolas. So now we've got the variable that controls the amplitude. We've got the variable that controls the period. This variable controls vertical shift of the graph, and this gives us, horizontal shift of the graph, and this gives us vertical shift of the graph, okay? Just like before, amplitude, period, horizontal, vertical, okay? So let's see how that works and what it is going to look like. If I give you g of x equals 2 sine of 4x plus 3. So 2 sine of 4x plus 3. Well, if you forget this plus 3, we've already done the rest of that, amplitude, period, right? We're just adding this to it. So that's just going to change where we put our points and how we graph it. So we're going to start off the same way. We're going to talk about the amplitude. The amplitude is the coefficient of the trig function, which in this case is 2, period. We're going to do 2 pi over our b. B value is the coefficient of x. So it's 2 pi over 4, which is going to give us pi over 2 is our period. There's no parentheses. So just like when we did parabolas, if you don't see parentheses, there's no horizontal shift whatsoever. What does that mean? What that means is we are starting at 0 still. All right, we're still starting at 0. Our starting point did not shift left or right. What's going to happen is that our center of the graph isn't going to be the x-axis. It's going to move up or down, and since it's plus 3, that means it's going to move up 3 units. So what we need to do is, instead of starting at 0, we're going to go up 3 units and say, okay, this is now the center of my graph. And it helps if you draw a dotted line. All right, so that's the center of the graph. My amplitude is 2. All right, I don't go up 2 and down 2 from 0. We go up 2 and down 2 from the center of the graph. So that means the maximum point on my graph is going to be 5, and the minimum point on my graph is going to be 1. It's the exact same thing, but instead of being centered around 0, it's centered around 3. So I go up 2 from 3, I go down 2 from 3, up 2 gives me the max, down 2 gives me the min. Okay. Now we just need to find our points. So we said the period is pi over 2, so we're going to go from 0 to pi over 2. So our graph is going to start at 0, it's going to go to pi over 2. Okay. Halfway between pi over 2 and 0 is going to be pi over 4. Halfway between 0 and pi over 4 is pi over 8. And again, if you want to think about what you're doing here, that's 1 pi, that's 1/8, or 1 pi over 8. That's 2 pi over 8. This would be 4 pi over 8, so this is 3 pi over 8. So this would be 3 pi over 8. All right. Again, if you need to work it out, anytime you need to find an average, you add 2 numbers up and divide by 2, or even easier, give them all the same denominator. Whichever one you see is the largest one, give them all 8. So make them all something over 8, and you'll very easily figure out that that's going to be 3 pi over 8. Okay. What's left then is to draw the curve. It's sine. So sine starts at the center of the graph. So it's going to start here. And then at the first quarter, it's going to go up to the max. It's going to come back to the center of the graph. It's going to go down to the min. It's going back to the center of the graph. So our curve is going to look like that. So essentially, if I shifted this entire graph down 3 units, if we got rid of this, it'd be centered around this axis. So all we did was take that graph and move it up 3 units. Okay, so that is a vertical shift. The hardest part about graphing these trig functions is the fraction part where you're finding the quarter points, but you have to have those labeled. When I'm looking for graphs, or when you're going to be looking for graphs in the future, The points you want to have labeled are your vertical midpoint, the max, the min, your horizontal starting point, the quarter point, the half point, the three-quarter point, and the end point. So you have 1, 2, 3, 4, 5, 6, 7, 8 points that have to be on the graph. Some of them, it might be fewer, because if we were centered on the graph, 0 would be both the horizontal and the vertical starting point. So you need to have all of those set up. Okay? All right, let's do one more, and this time we're going to shift it horizontally, which is going to be probably the most involved type. And you will get graphs that are going to do both. Obviously, a graph can shift vertically, horizontally. It can change its period. It can change its amplitude. It can do everything. But I want to keep them kind of separate from each other so you can see what's going on with these. All right. So if we have g of x, that's a horrible color. I can barely see it, so I'm going to assume that you can't see it. So we'll go back to something that works a little bit better. G of x, much better. G of x is equal to 5 cosine of 1/2. And if it's a horizontal shift, we're going to have parentheses. So 1/2 of x minus 3 pi. Okay? So again, this is A, this is B. So that's what's going to give you your amplitude and your period. So we know the amplitude is 5. We know the period is 2 pi over 1/2, which is 2 pi times 2, which is 4 pi. All right. So I've got the amplitude, I've got the period. So what's going to happen is I'm going to draw my x and y axis. There's no vertical shift, so I do know that my amplitude's 5, so my graph is going to go up to 5. It's going to go down to -5, and it's going to be centered around 0. But my graph is not going to start at 0 because I have a shift. And if you recall when we did parabolas, if this is negative, we're saying, what do I have to plug in for x to make that 0? Positive 3 pi, right? So we're starting at 3 pi. If this was a plus sign, it would be a negative starting point, okay? But since it's a minus sign, we're just going to pick a point. It doesn't have to be perfect. We're going to call this 3 pi. Obviously, we can't put it right here because that's 0. We're going to need to put it out here somewhere. So that is 3 pi. So we're starting at 3 pi. We now have to find the end point. Your end point, the end is equal to the starting point plus the period. So I know where I'm starting. I know what the period is. So 3 pi and 4 pi means we're going to end at 7 pi. Because if I'm starting here and I need to travel 4 pi to get a complete rotation, I'm going to go from 3 pi to 7 pi. All right, so my graph is going to fall here. Midpoint, 3 plus 7 is 10. Half of 10 is 5. So your midpoint's 5 pi. Obviously, right between 3 and 5 is 4 pi. And between 5 and 7 is 6 pi. So now we have all of our quarter points, and all that's left is to draw the curve. We're doing cosine. What does that mean? That means we're starting off at the maximum point on the graph. So my starting point is here. Horizontally, vertically, my maximum point is here. So cosine is going to start there. In the first quarter, cosine drops down to the middle of the graph. At the midpoint, it's down at the minimum value. It's back to the midpoint, and then it's back to the max. We have our points. We draw our curve. And there is your cosine curve. Okay? It's just a lot of practice with these. So working with fractions, putting together piece by piece. But you can just imagine if I were to put a plus 2 here, all that would happen is this entire graph would move up 2 units. This plus 2 has nothing to do with these values. It just means that we'd start at 2, right? That'd be the midpoint. My amplitude's 5, so we'd go up to 7, and we go down to -3. All right, and this whole graph would just shift up 2 units. That's all. Okay? Hopefully that helps. Let me know if you have any questions, and enjoy graphing.